To get rid of the 2, guess what? E to the 3x power is equal to 25. It's the same thing. You want to avoid the fractions? Okay, just go in the order of operations. Now, what do I do? Okay, what's the problem here? My variable's in the exponent. We got to go to log. What's my base? My base is e. My base is e. Let's go to natural log. Look, Wager, close your eyes. I'm going to show the class, but not you. How do you get rid of the e? The inverse of e is what? Natural log. So let me take the natural log of both sides if you want. Technically, that's what we're doing. But I showed you the conversion way because I think it's easier. Some teachers teach you this way. Now, what's the natural log of e going to do? Natural log of e are inverses. These are just canceled, and I'm left with 3x. 3x is equal to the natural log of 25.
How do you do that the other way?
It's the same thing. Okay? What I had here is this. I'll do it on this side. What's the base? My base is e. I now have to go to log. What's log base e? Natural log of my value, 25. Logs are equal to the exponent. And my exponent is 3x. And look, you get the same dang thing. I mean, it's same either way. Can I do natural log of 25 on the calculator? I think I can. Natural log of 25 on the calculator. 3.219. What's after the 9?
8.
An 8. So can I make that a 3.2?
No, it's a 2.2188.
88, so we'll make that 219. Say it was 3.2198, like we thought, then you would make that 3.220. What? Now, we got to solve for x by dividing 3 on both sides. So my x value is 1 point, don't tell me. 3 goes into 21, 7 times 0, 7, 3.
Yeah.
Okay. That's amazing.
Is that it?
For that problem, yes.
No, I meant like...
The lesson, let's increase the difficulty a little bit here.
Are we watching Pyro next hour?
4, we'll start off with a medium difficulty one, and then we'll crank it up. 4 to the x minus 2 power is equal to 0.5.
X minus 2 or
Negative x over 2. Sorry. 4 to the negative x over 2 power is equal to 0.5. Now, you may notice something about this. And what I'm going to do is the people that may notice something and people that may not notice something, I'm going to show you going to get the same thing anyway. Okay? You said we're going to convert to log, which is correct. Does anybody else notice something about this? Okay, my exponent is 0.5. All right, let me write this as a half, just to be that way.
That's 1. Okay. That's negative 1. It's just square root.
Well, we could convert this to like bases if you want, right? Because 1 over 2, I know the square root of 4 is 2. And what is the square root power? What is the square root as a power? Isn't it a half? And since it's on the bottom, right, this would be 4 to the negative 1/2 power. Because the 1/2 of 4 goes down to the bottom, right? Because it's negative, it goes down to the bottom. And 1/2 power is square root, and the square root of 4 is 2. I mean, so now it kind of matches up. So you can say x equals 1, because negative 1 over 2 is negative x over 2. So that means x is 1. That's the easy way if you notice it. Okay, you didn't notice it. Most of us in here probably didn't notice it. So let's convert with the common way to do that we can use for every problem. What's my base? My base is 4. So let's convert to log base 4. Log base 4 of 1/2 is equal to my exponent, because logs are equal to the exponent. I'll say it over and over. Now, this causes a little bit of a problem because I can't do log base 4 in the calculator. So what I have to do is change a base. Here's how I like to do it. Natural log of 1/2 over natural log of 4. base on the bottom when you do change a base. Put the B on the B. Put the bob. Okay? You put the bob, you got your base on the bottom, you're going to convert, now I can type this in the calculator, and this is equal to negative x over 2. Somebody, natural log of a half divided by the natural log of 4. Let me guess, negative 1/2, right? Now I just have my, okay, I got my negative x here is being divided by a negative 2, so let's multiply it by a negative 2 on both sides. Okay, so this is all canceled, so x is 1. Granted, you do either way if you notice that the bases are the same, that's fine. Okay, you do it either way, you're going to get the same thing. All right? Let's look at this. E to the 2x minus 6e to the x plus 8 is equal to 0. Listen to me very closely after you write this equation down. I need to know if there's somebody in here that recognizes something about that. What does this equation suggest to you? What? Factor tree. You might be on the right track a little bit. What is that?
Quadratic.
This is a quadratic. Right? You said it right. How do I notice that? Well, if I were to write this, don't write this down, you can just watch this. This is e to the x quantity squared. Right? Because e to the 2x, power to a power, you multiply powers, right? So e to the x squared is really e to the 2x. Look, this is my squared term. This is my linear term, and there's a constant. So it looks like that this might be able to be, you might think of as reverse FOIL, if you want. Okay, they'll all look like that because I have a quadratic, I got a linear, and I got a constant term. And if I have written first e to the x squared, my first is e to the x, and my first is e to the x. Okay, because e to the x times e to the x is e to the x squared, or e to the 2x, right? Now here's the million-dollar question. What are my factors that of 8 that add up to 6? 4 and 2, we're going to put those in here. Here's the $2 million question. What are my signs going to be if I have a minus then a plus? Minus, minus. Okay, now what I have in this problem are 2 exponential equations, both with the natural base. Okay, so what I could say is this: e to the x minus 4 equals 0, or e to the x minus 2 equals 0. And I solve them separate, you're going to get 2 solutions here. You're going to get 2 solutions because it's written as a quadratic. You're going to get 2 solutions because you have 2 factors. So either e to the x equals 4, or e to the x equals 2. You got to solve them both. How do you solve this? How? Natural log of 4 is equal to x, right? The natural log of 2 is equal to x, my exponent. So those are my 2 solutions. X equals natural log of 4, comma natural log of 2, or if your book says 3 decimal places, you type them in the calculator.
1's 1.386.
And?
0.693.
There they are. 2 solutions.
If you wouldn't have seen that, would you have to take the square root and then at some point get 2 different answers?
No, the only other way really to do that is to replace, okay, your e to the x with a variable. And then what you might have there is a quadratic formula kind of thing.
So pretty much just do that.
You want to factor it that way, okay? Last problem of the day. And then we'll see how many of these we can do here. All right? Last problem of the day. Last problem of the day is the hardest problem of the day. This is about as hard as it gets for right now. 24 over negative 50 plus e to the 3x power is equal to 95. we're going to start getting into this interest formula, finding out how much money I need to invest in order to retire, looking at how much money needs to be in my funding in order for me to go to college. Or you have a child someday and you want to start investing money for that child. Okay? And what you want to do is send that kid off to college someday. How much do you need to invest at a certain percentage in order to have enough for that kid going to college someday? Those are good questions, am I right? I'm going to retire in about 20 years. How much money do I need to start investing in order to make enough that I can live off of so that I can survive when I'm retired? Those are good questions. Your equations might look something like this. I noticed two things. My variable is in the exponent, and my variable is where? In the bottom of a fraction. So let me first put that over 1, and I want to get the reciprocals. I want to get that variable out of the bottom. So let me say 24, I'm just flipping these over. I'm going to say negative 50 plus e to the 3x over 24 is equal to 1 over 95. That looks a little bit better. Now I got to get rid of some stuff. Let me multiply both sides by 24 to get that out of here. And when I multiply this side by 24, it just goes up on the top. Take your 1, turn it into a 24. So my new equation is negative 50 plus e to the 3x equals 24 over 95. And again, decimals are probably a little bit easier to work with. Somebody give me 24 divided by 95 as a decimal, please. 0.253. Now, I got to get rid of this negative 50. So let's add 50 to both sides. What I have here is e to the 3x power is equal to 50.253. And now I have an equation that I recognize. Now I have an equation that I can deal with. What do I have to do? I got to convert it into natural log. Natural log of my value, 50.253, is equal to my exponent because logs are equal to the exponent. Memorize that sentence. 3.917. Divide by 3? Or did you already divide by 3?
I did not divide by 3.
Okay, let's divide by 3 right on the calculator and get it right away.
It's
1.30.
6.
6. Sounds good to me. There it is.